Hey everybody, I've got a really exciting topic to talk to you about
Hey,
today.
Jason, did you get that Slack message I just sent you?
Hi John, I'm kind of in the middle of something. Can I get back to you in just a little
Yeah,
bit?
sure. I'll
All
see
right.
you later.
Thank you. You guys ever have a coworker like that loves to chat things up but might interrupt your work a little bit? Well, believe it or not, it's a little bit like quantum computing. Let's talk today about quantum error suppression and specifically a technique called dynamical decoupling. As you know, quantum computers can be a little noisy and error prone, and one of the issues with them is idle qubits. So these are qubits that are on a circuit that for a certain amount of time they don't have any activities going on with them. And idle qubits can cause two types of errors. The first of these is decoherence, where the qubit loses a little precision in its state. And the second error is crosstalk, where that idle qubit might interfere with a qubit on either side of it. A little bit like my coworker John interrupted me and distracted me, the hardworking qubit, from doing my job. So there is a technique for dealing with idle qubits, and that is to keep them busy. Just like if I can keep John busy, he doesn't have time to interrupt me. And the way you do that, though, is how do you do that with a qubit and not interfere with that calculation you're trying to do in the circuit? Well, if you look at the X gate for a qubit, what that does is it flips the state. It's also called a NOT gate. It flips the state, and if you apply another X gate, it will put the state back to where it was. Together, these two X gates or NOT gates are called the identity, and they allow your qubit to stay busy without actually changing the state of the qubit. Now, the good news is Qiskit, which is the open source software development kit for quantum computing, will allow you to implement this dynamical decoupling by just setting a couple flags. There's no need to go into your circuit and insert pairs of X gates along the way. Dynamical decoupling is one of the ways we're trying to make today's quantum computers more useful for real-world problems. You can read more about dynamical decoupling and quantum error suppression in the links in the description.